Techniques of knowledge representation. So we talked about a lot about knowledge, and then representation. How do we represent that? So it can make easier for computation, for computing purposes. The first one is a logical representation. It's a language with some concrete rules. It deals with propositions, statements. Remember the true and false kind of thing, and has no ambiguity in representation. Very clear cut. Logical representation means drawing a conclusion based on various conditions. This representation lays down some important communication rules as well. Consists of precisely defined syntax and semantics. Okay, the sound which supports the sound inference conclusion. Each sentence can be translated into logic using some syntax and semantics. Syntax is the exact way of doing it. Semantics translates into the meaning of that. Logical representation can be categorized into two categories: propositional logic and predicate logic. The advantages are that easier to represent and do logical reasoning. It is the basis for programming languages, the most famous being Prolog, programming in logic. Disadvantages: they have some restrictions and are challenging to work with. Not everybody understands the way it is, but still language has been used. It may not very natural, and the inference, the conclusion may not be so efficient in general. Semantic networks, very interesting. An alternate to predicate logic for knowledge representation. It's semantics, like language. A canary is a bird flies, and a bird is an animal eats, and this kind of thing. So you have a very clear cut, very simple way of representing knowledge in the form of graphical networks connected through these links, right? Canary is a bird is an animal, animal eats, animal drinks, and so forth. And each node represents each of these, followed by the representation links. They categorize objects into various categories, and as I said, very easy to understand. Is a relationship, kind of, as I mentioned earlier on. Then we have statements like Jerry is a cat, Jerry is a mammal, and so forth. Several of these. As you can see, one on the graph here, how things are linked. So as I said, there's another one. Okay, Jerry is colored, so white, and Jerry is a cat, and cat is a mammal. As I said, this is how you build up. So it actually looks very intuitive and very interesting and easy to understand. Drawbacks are there: the computationally expensive, takes a lot of computing resources. Frame representation. Frame is like a box in which you have collection of attributes, characteristics, and they describe various things that happen in the world. And in AI, divides the knowledge into substructures by representing stereotypes, situations, typical situations grouped together. They have slots and values. Slots are those attributes, and some values: color, size, okay, distance, and so forth. Okay, and you can name those slots, and sometimes called facets as well. Facets are those situations where you have what we call as active values. So if you need something, it is computed there and then. Otherwise, the wherewithal remains there, but you don't have data stored in your database as such. Frames have led on to actually the discovery, formulation of what we call as classes and objects. Okay, so in fact, if you just take a break here, you will realize that AI has also contributed to the development of computer science as well. The concept of objects actually has been kind of transformed, evolved from the concept of frames. However, one frame is not enough, and you need to have multiple frames, to collection of frames which are connected to convey the representation. So for example, as you can see here, you have a frame for a book. So you have slots and you have filters, like title of a book can be artificial intelligence, genre, computer science, author, Mr., ABC, whatever. So this is like a typical frame. Advantages I've just discussed. Representation is comparatively flexible, easy to add new slots. However, as I said, computationally and then other things, it is used and evolved into objects. So they're being quite frequently used in inference mechanism. Deriving new information can be easily processed. The next one after this are production rules. I've used various words for this. If then, okay. So if certain conditions, then certain actions. If certain condition, then another action, and so forth. And easier to understand as well. This is what we have learned from experts as well, and which has led to the development of expert systems. So mainly three parts: set of production rules, where the rules, as I said, are if then conditions. You have a working memory where your fact for the current position, current state is in your memory. And then what we call as a recognize act cycle, right? You match the rules to the working memory, right? You recognize and then you act upon those rules. You carry out those rules, perform the actions. That's a continuous process. You check for conditions, carry out with it. The if condition part, the left hand side determines whether the rule can be applied or not if they match with the facts in the working memory. So working memory contains, as I said, some current states, as current facts, as well as static facts that you might have built over time. And then you can continue using this. And every time a new situation arises, maybe a new rule is ready to execute. The advantages, of course, are that it's very easy, intuitively. You can actually talk to experts, get their knowledge, code them, and start working. Sometimes there are issues with what we call as conflict resolution. A number of rules are there to be fired. Which one should you fire? Okay, so that's conflict resolution. The very simple situation is you're going on a road and you know when there is the traffic signals goes red, you need to stop, and when it's green, you can move on. However, at the back of your mind, you also have an emergency rule. Somebody comes in front of you there and then. You don't have to wait for a red signal or something else. And that's when that rule, the emergency rule, that takes over. And all other rules are forgotten. Okay. Other rules can be if a bus stop, if at bus stop and bus arrives, then take some action, get into the bus. That's a rule. They're expressed in natural languages, very easy to understand, highly modular. You can easily remove the rules. The only disadvantage, a major disadvantage, is that they don't have the ability to learn, okay, add to their knowledge. That's the limitation. So a lot of effort has gone on into developing very good, very comprehensive expert systems using if-then rule approach, production rules. However, there is no provision for learning, adding to the rules themselves. And as I said somewhere else, learning is a very, very basic component of human beings. So yes, a very advanced, very comprehensive expert system without the ability to learn on its own. What would happen today? If I built one, I'm going to then keep on adding, revising the rules, updating one, adding more and more. So there's kind of direct human interaction involved. We want to avoid that. That's not what intelligent agents do. Intelligent human agents or AI agents. So somehow that has to be built in, but this is a disadvantage. And once that execution is over, this working memory, you have this statement of facts and then execution, then that is gone. Just like a doctor. Every new patient brings a new set of facts. Of course, some basic medical knowledge still remains there, right? So yes, advantages and disadvantages. Scripts, another way of representing a knowledge. So summing up, a script can be defined as a structural representation which describes an event of a certain type in a generalized stereotypical manner, and then taking into account a particular context. So you can have various scripts performing various functions. Okay, so it's like functions and you have scripts. They're actually kind of identical, the action that you perform. I am not going to go into details of these preconditions, how they're activated, because I think this should suffice in terms of understanding what it is. uh, Facts, that's a very powerful mechanism. A facts is a statement of a everyday life that you do, truth statements, which is generally said true or false. And there's a proposition, says proposition A, it is raining, and a proposition B says I have an umbrella, right? So you, based on this, you insert another proposition, say I will go to school, for instance, right? So rules are, as I said, form of representation. You can then have compound rules. Okay, said earlier on, if it is raining, then I'll not go to school. That can be another rule as well. Okay, you don't want to go to school. So on the left hand side, the if condition is a premise which feeds to the rule, and a conclusion, the action that the rule actually tells you what to do. Ontology is another way of saying, describing the structure of information or knowledge. Okay, and sometimes it is good. It is able to remember, we used knowledge and meta knowledge, and then philosophical as well. So when you're talking about knowledge, and ontologies are the one that you need to use, and you describe at a very higher level. Then we need to know a little bit about knowledge engineers and domain experts. If you want to build and execute and modify an expert system based on if then rules and so forth, that person is known as a knowledge engineer. And the person who will tell you about these rules, like the doctor or a mechanic or a software engineer, right? He or she is known as a domain expert. However, once again, at the risk of repeating, these systems don't have the ability to learn, increase their knowledge on their own. So that's one of the limitations. So here was a brief review of these representation techniques. I hope you found them useful. We'll use them as we go along in the upcoming videos. Thank you very much.